Today we're going to look at 4.2 trigonometric functions and the unit circle. The unit circle is built off of triangles, and the special right triangles that we're going to talk about are the 30, 60, 90 and the 45, 45, 90. And I would recommend having the ratios of these sides memorized for the ACT. So across from the 30-degree angle is x, and across from the hypotenuse is always twice that in a 30, 60, 90. So 2x. And then the side across from the 60 is x root 3. Let me derive that for you. So the reason why that is, just pretend that this is an equilateral triangle, meaning all of the sides are the same. So if all of the sides are the same, then all of the angles would be the same. So this is a 60, 60, 60 degree triangle. Now, if I were to drop a line that bisects that angle, then this angle up here would be 30. And so now I have a 30, 60, 90 degree triangle. Now, if this side were 1 and this side were 1, then the length of this side would also be 1, but my bisector would make this a half and this a half over here. So now you can see if I'm missing the side across from the 60, it would be a squared, which is 1/2 squared, plus b squared, we don't know that side, so I'll call it x, equals c squared, which is 1. So now you would have x squared equals 1 subtract 1/2 squared is a fourth. So x squared equals 3/4. And then when you square root it, you're going to get x equals root 3 over 2. So this side here would be root 3 over 2 when this side is a half and this side is 1. So now if we come down here and we look at this special triangle, across from the 30, if this were equal to a half, then twice a half is going to be a whole. And the hypotenuse, this would be the radius of the unit circle, which is 1. And then if you plug in a half for x, then you would get 1/2 times root 3, which is root 3 over 2. So these are going to be the sides of that special triangle in the unit circle. Same thing here, you could derive why this is x and x root 2. The easiest way to remember this is an isosceles triangle. So across from the 45s are always going to be the same thing. And then across from the hypotenuse is x root 2 in length. So let's say that the x root 2 is equal to 1, which is the radius of the unit circle. Then if you were to divide both sides by root 2, you would have x equals, rationalize that, and you get root 2 over 2. So therefore, we could say, all right, if this side is equal to 1, which is the length of the radius in a unit circle, then this side over here would be equal to the length of root 2 over 2, and this side here would be equal to root 2 over 2. So now let's coordinate this with sine, cosine, tangent, cosecant, secant, and cotangent. So looking at this, the sine of a value is going to be equal to y on the unit circle. The cosine would be equal to x if we're looking at a point on the unit circle. And then the tangent is going to be y over x. You can see that sine goes with cosecant, which is just the reciprocal. Cosine goes with secant, which is the reciprocal, and tangent goes with cotangent, which is the reciprocal. So let's jump to the unit circle and see what this is all about. So a unit circle always has a radius of 1. So from the origin to the edge of the circle is going to be 1 unit. So this would be 0 degrees or 0 radians. And if I were to pick point T on the circle, this is going to be right 1 and up 0. Now on the unit circle, the x value is going to be your cosine. The y value is going to be your sine. And then y over x is going to equal your tangent. So in this case, 0 over 1 is equal to 0, which means the tangent would be equal to 0. Okay, so let's look at, we call these the quadrantals when you're on the axis. So up here is 90 degrees, or in radians, it's pi over 2. And that point on the unit circle is 0, because we don't go left and we don't go right, and we go up 1. So what we would say is the cosine of pi over 2 is 0, and the sine of pi over 2 is equal to 1, and the tangent of pi over 2 is undefined because it would be 1 over 0. So let's come over here. Here, this point T on the unit circle, is going to be left 1 and up 0. And this would be at 180 degrees, or at pi units. So basically, we would say the cosine of pi is equal to -1, and the sine of pi is equal to 0. Okay, looking at this quadrantal down here, we travel 270 degrees. And again, we go in this direction, or 3 pi over 2. So looking at this point on the unit circle, it's 0. We didn't go left or right, and we went down 1. So what this would mean is that the cosine of this angle, 3 pi over 2, is equal to 0, and the sine of 3 pi over 2 is equal to -1. We would say the tangent of 3 pi over 2 is equal to -1 over 0. And then you come back here and you would have 360 degrees. And honestly, we're going to use radians a lot more than we are degrees. So if I said, what is the cosine of 2 pi? It would be 1. And what is the sine of 2 pi? It would be 0. So again, looking at this, the sine of t is equal to the y value, and the cosine of t is equal to the x value. So now let's look at when we are at the next special angle, which is 30 degrees. So if this is 30 degrees, so from here to here is 30 degrees. And this in radians is pi over 6. You should have that memorized. So you can say 30 degrees or pi over 6. And if I were to look at this point right here on the unit circle, how we're going to get that point is we're going to look at this right triangle. So if I were to make a right triangle here, and you can see that this is a 30, 60, 90 degree triangle. And remember that the radius of this is always 1. And so that means that across from the 30 degree angle, this side is going to be a half. And you can see that this is the y value. So this is a half. And then if you were to do a squared plus b squared equals c squared, the length of this side is a little bit longer than a half, and it's √3 over 2. √3 over 2. And so that's the x value. And so what this means is the sine is the y value. So what's the sine of 30 degrees? It's 1/2. Or what is the sine of pi over 6? It's 1/2. And then what is the cosine of 30 degrees? Or what is the cosine of pi over 6? And the cosine of pi over 6 is √3 over 2. Okay, let's look at the next point in the unit circle. This is going to be right here. And this is going to form a 45, 45, 90-degree triangle. So this angle from here to here is 45 degrees. Now again, we know the length of this is going to be 1. And so if the length of that is 1, then we know that the two sides are going to be root 2 over 2 and root 2 over 2. So the x value is root 2 over 2, and the y value is root 2 over 2. And then if I asked you, so what is the cosine of 45 degrees? You would say root 2 over 2. Or I could use the radians. What is the radians of pi over 4, which is the same thing as 45 degrees? It's root 2 over 2. And boy, that line I didn't draw very straight, but okay. And then let's look at this point right here. And let's do that one in blue. So here's my last triangle. So this triangle here, that point on the circle, is a special right triangle. And this time the angle from standard position to here is going to be 60 degrees. So up here is the 30 degrees, the smaller triangle. So across from the 30 degrees is going to be a half. And then across from this angle in here, which is 60 degrees. So this side is a little bit longer. It's going to be root 3 over 2. And then the length of this, which is from the center of the circle to the edge of the circle, is 1. And so looking at the angle, we're talking at 60 degrees or pi over 3. Pi over 3 is the radian, 60 degrees. And so if I said, what is the cosine of 60 degrees, it would be this length right here, which is the x value, which is 1/2. And if I said, what is the sine of 60 degrees, it would be this value, which is root 3 over 2. So now the cool thing about, if you know the values of the x and y value, or the cosine and the sine in the first quadrant, all around this circle, you're going to get these same triangles. So this point here is going to be a reference angle. Here, that reference angle is 30 degrees. So if we came all the way, half circle is 180, and we subtract 30 degrees, then this is going to be 150 degrees. And then in radians, it's going to be 5 pi over 6. Because if you take pi and you subtract the 30 degrees, which is pi over 6, if you get common denominators, 6 pi over 6 subtract 1 pi over 6 is 5 pi over 6. So that's 5 pi over 6. And the cool thing is this triangle is going to have the same ratios. And so the x value is going to be root 3 over 2, and the y value is going to be 1/2. But now we're in the second quadrant. So when I draw this triangle here, because I'm in the second quadrant, to get to this point, I'm going left and then I'm going up. And so the cosine is always negative in this second quadrant. So if I said, what's the cosine of 5 pi over 6? You would say negative root 3 over 2. If I said, what is the sine of 5 pi over 6? You would say positive 1/2. And then looking at this point right here, it's going to have a reference angle. Here's the reference angle here of 45 degrees, which means the x value is root 2 over 2 and the y value is root 2 over 2, because we're looking at this triangle here, which is the same length as the triangle over here. Now the only difference is this point is going to be left, which makes that negative root 2 over 2, and then up, which is positive root 2 over 2. So if I said, what is the cosine of, and you go, again, to find this in radians, you would take pi and you would subtract pi over 4, because this reference angle is pi over 4. This would give me 4 over 4 pi minus 1 over 4 pi is 3 pi over 4. So in radians, this is 3 pi over 4. Or in degrees, you would take 180, subtract the 45, and you get 135 degrees. So what's the cosine of 3 pi over 4? Negative root 2 over 2. What is the sine of 3 pi over 4? Root 2 over 2. Okay, and then the last triangle is this point here, and it's going to have this reference angle of 60 degrees. So you've got the 1/2, but you went left, so that's negative, and then root 3 over 2. As far as degrees, 180 subtract the 60-degree reference angle is going to give you 120 degrees. And pi subtract pi over 3. Remember in radians, that reference angle is pi over 3. So if you take pi, subtract pi over 3, and then you get common denominators, it's 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. So this here is 2 pi over 3. All right, so let's look at the third quadrant. Now what we're going to be doing is taking the reference angle. So here is the 30-degree reference angle, and then you're going to have a 45-degree reference angle, and then you're going to have a 60-degree reference angle. And again, basically what you're doing is you're taking this point and you're bringing it up like this, and you're making a right triangle. And that angle in here is 30 degrees. Reference angles are always positive. So 30 degrees or pi over 3. So if you take 180 degrees and you add 30 degrees, you get 210 degrees. And then if you take pi and you add pi over 6, then you would have pi plus pi over 6, and then the common denominator is 6. So 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. So I'll put that in green. So this is 7 pi over 6. Okay, and so these points here are going to be the same as these triangles with the 30-degree or the pi over 6 reference angle, which is going to be root 3 over 2 and 1/2. Now in this quadrant, you're going to be going left and you're going to be going down. So both of these values are negative. All right, and I'm going to go ahead and stop this video and fill in the rest of these, and I'd like you to go through and see if you can fill in the rest of them as well, and then just check your values. So I filled the rest of this unit circle in for you, and you can see that really all you need to know is this first quadrant and the quadrantals, which are the reds, because blue is going to be same values in all 4 quadrants except for the signs. Here you go left and up, so there's a negative. Here you go left and down, so both are negative. And here you go right and down, so the first one's positive and the y value is negative. And that's the same with all of these. So really you just need to know the ones in the first quadrant. Now, all of the trig functions are positive in the first quadrant. The sine, the cosine, and the tangent, which is y over x. Now, I just want to remind you, the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So I put a heart because they go together. And when you take the reciprocals, they're going to have the exact same sign. So that means all 6 of these trig functions are positive in the first quadrant. Now, in the second quadrant, because we go left and then we go up, that means that the sign is positive. The y value is positive. And who loves sine? Cosecant. So cosecant would be positive. In the third quadrant, we go left and we go down. That means that 2 negatives make a positive. So when you put y over x, tangent is going to be positive, as well as who tangent loves, which is cotangent. In the fourth quadrant, the x values you're going right are positive and your y values going down are negative, meaning that your x values are your cosines. Cosine's positive, and who loves cosine? Secant. The mnemonic to remember: what is positive? All positive in the first, A for all. Students, S in students stands for sine, and sine loves cosecant. All students take. Take stands for tangent, and cotangent goes with it. All students take calculus. Calculus, C, stands for cosine, and with cosine goes secant. So that's how you can remember where we are positive. All trig functions in the first, sine in the second, tangent in the third, cosine in the fourth, along with their reciprocals. So if my unit circle was a little bit too messy for you, here is a typed version that you can use to fill in your unit circle. Here we go. Use your unit circle and let's practice evaluating some of these 6 trigonometric functions. Sine of t. Well, what happens when t is pi over 6? So we are looking for the sine of pi over 6. In the unit circle again, remember that pi over 6 was right here at your 30 degrees. Pi over 6 and 30 degrees are the same thing. And we remembered that the x value was root 3 over 2 and the y value was 1/2. So what would the sine of t be? It's the y value, which is 1/2. The cosecant of t is the reciprocal, which is 2 over 1, which equals 2. Cosine is root 3 over 2. And the secant is 2 over root 3. And you want to rationalize that, so you'd multiply the top and bottom by root 3. The square root of 3 times the square root of 3 is simply 3, and 2 times root 3 is 2 root 3. Okay, looking at the tangent. Tangent means you're going to take y and put it over x. So if you take 1/2 and you put it over root 3 over 2, then when you have the same denominators in a complex fraction, they cancel. So that gives you 1 over root 3. Let me flip it and then I'll rationalize it. You flip it and you get just root 3. And then rationalized is going to be root 3 over 3. Okay, so 5 pi over 4. What I recommend doing is simply look at just the pi over, ooh, that's not a highlighter, darn it. Just simply look at the pi over 4, and then we know that 5 pi over 4 is in the third quadrant. And so we know that the tangent's going to be positive and the sine and cosine and who they love will all be negative. So here we go. The sine is root 2 over 2. The cosine is root 2 over 2. But don't forget, we are in the third quadrant, so both are negative. The tangent, when you take the same thing on the top as the bottom, you're going to get the number 1. When you flip 1, you get 1. When you flip this one, you're going to get -2 over root 2, and then you rationalize by multiplying top and bottom by root 2, and that's going to give you -2 root 2 over 2, but then the 2's are going to cancel, so that equals just -root 2. And so this one also would be -root 2. And that one's 1. Okay, when t equals 0, so we're looking at this point right here on the unit circle, which is right 1 and up 0. The sine is going to be 0, the cosine is going to be 1, and the tangent is 0 over 1, which equals 0. Now, anytime you take the reciprocal of 0, think of 0 over 1, and the reciprocal is 1 over 0, which is undefined. And then the reciprocal of 1 is 1, and the reciprocal of 0 is always undefined. Looking at pi. So pi is this point over here to the left, which is -1, 0. The x value is the cosine, the y value is the sine, and the tangent is y over x, so 0 over -1, which equals 0. You flip 0, you get undefined. You flip -1, you get -1, and you flip 0, you get undefined. And there's your values for example 1. So you're supposed to be able to do example 2 without a calculator. So the cosine of 990, we want to find a reference angle. So we know 360 is a full circle. 360 and 360 is 720. So if you take 990 and you subtract 720 degrees, then you get 270 degrees. So basically what we're doing is we're going 360, 720, and then another 270 degrees. Well, that quadrantal is at 0, -1, and we know that the cosine is the x value. So what is the cosine of 990 degrees? It is equal to 0. 5 pi over 3, so you should be able to graph 5 pi over 3. It is going to be in the fourth quadrant. 6 pi over 3 is 2 pi. So it's a little bit short of 2 pi. So we come around here, and the reference angle is going to be this pi over 3. So here's your reference angle. And so when we look at 5 pi over 3, we're in the fourth. This point right here is going to be at 1/2 and -√3 over 2. And so tangent of 5 pi over 3 is going to be y over x. And the cotangent, you're going to flip that and put x over y. So if I take 1/2 over -√3 over 2, again, those denominators are the same, so they cancel, and it gives me -1 over √3, which is √3 over 3 when why did I put 2? Darn it, it's starting to get late. √3 over 3 when I rationalize. So that's going to be your B. And don't forget the negative, because only cosine is positive in the fourth. Cosine only. All right. So tangent's going to be negative. Okay, last one. Let's look at the sine of 225 degrees. So you would go 90, 180, 225. So there you are in the third quadrant. The reference angle, so if this is 180, you went 225 subtract 180 is you went 45 degrees past. And 45 degrees is a special. So we know what the sine of 45 is. It's root 2 over 2. Now, because I'm in the third quadrant, it has to be negative root 2 over 2. So a periodic function is a function y equals f of t is periodic if there is a positive number c such that f of t plus c is equal to that same value. So we're looking at the unit circle and we're saying, when am I going to get those repeating values for sine, for cosine? And the sine and the cosine, we get the exact same values every 2 pi. So sine and cosine are periodic, and the period is 2 pi. The period of tangent is pi. We get the same repeating values every pi unit. So on this one, it's going to be kind of cool because what we're going to do is we're going to figure out the sine of 3,601 pi over 2 without a calculator. So basically, we're going to use the periodic function to figure out what the sine of it is. So first, we have to figure out where we are. So you take 2 and you divide it into 3,601 and you get 1,800. So and this is a remainder 1/2, so 1,800 and 1/2. So this would be 1,800, and then you still have this half pi left. So if we were to do 2 pi, 4 pi, 6 pi, you notice this is even. Then after I keep circling around and around and around and around, I would go a half pi, which is going to land me right there. And that value on the unit circle is 0, 1. And we know that the cosine would be 0 and the sine would equal 1. So therefore, what is the sine of 3,601 pi over 2? It's equal to 1. And you could throw it into the calculator and check, but it absolutely is 1. The last page is completely calculator. And what you're going to do is make sure that you always check the mode of your calculator to make sure you know if you are in radians or degrees. And if you see the little degree symbol, you know you're in degrees. So example 4a is degrees, and example 4b is radians. And then all you'll do is just type in sine and type in 42.68, making sure you're in degrees. And I would recommend do this on the calculator and then check that you get 0.6779, which rounded is going to be 0.677. Then you're going to go to mode again, and you're going to switch your mode. You'll see radians and degrees. You arrow over to degrees and you hit enter. Now, there is no secant on the calculator. So we know that cosine loves secant, right? So how we are going to find the secant is we are going to type in 1 over the cosine of 1.2. You'll type that in and you're going to get 2.759. So you round that is 2.760. 2.760. And I do recommend you try this on your calculator so that you can see that you're going to get these same values. All right, notes. And there's no key for secant. We must use 1 over cosine to represent secant because cosine is a reciprocal. Cosecant is going to be 1 over sine, and cotangent is going to be 1 over tangent of that value. So looking at degrees, minutes, and seconds, you should know where degrees, minutes, and seconds are on your calculator. Make sure you're in degree mode. You're going to put tangent and then plug in those values. and you are going to get 3.120. If you don't get that, then you should ask me for some help. All right, looking at example 5. When we're looking for theta, so we're looking for the angle now. This is called the inverse trigonometric function because we are looking at what angle does the cosine equal 5/12. So you go to your calculator, and this time you are going to hit second cosine, and it's inverse cosine. You should get this little -1, and you'd put in 5/12. You're in degree mode because it says find theta in degrees. And after you plug that in, you are going to get, let me look it up because I don't have my calculator in front of me. 65, oh, it's right on the page. 65.376. Ooh, it's starting to get late. All right, last one is B. The sine of t equals 1/3. So if I'm looking for t, I'm looking for the angle. So how you put this into your calculator is you're going to type in inverse sine. So it's second sine. And you'll have the inverse sine of 1/3. And that's going to equal 19.471 degrees. I recommend you try one more, example C, just to make sure you have it. What if you were looking for the cotangent of theta equals 3, and so you are looking for theta? Do you know how to put that in your calculator? Well, you know that cosine loves tangent. So what you can do is you can change the cotangent to tangent theta equals, but you have to take this value, which is the ratio of the sides, and you're going to have to flip it. So you would find the theta is going to equal the inverse tan of 1/3. And I always like to think of how are you getting theta by itself? You're taking the inverse of it. So the inverse tan. And throw that into your calculator, and you're going to get theta equals 18.435 degrees. If I was looking for degrees, I guess I should have told you look for degrees at the beginning. And they'll tell you if you're looking for degrees or you're looking for radians. All right, this is a really long video. Sorry. Bye.